Many fuel gases are used in the oxy-fuel process. Acetylene is the most commonly used fuel gas. Acetylene is an unstable gas and requires a special type of cylinder to safely contain the gas. Acetylene cylinders have a porous core which is saturated with liquid acetone. When acetylene gas is pumped into the cylinder, it's absorbed by the acetone within the porous core. This keeps the gas stable while under pressure. Under industrial guidelines, the maximum safe delivery pressure for acetylene is 15 psi. To minimize the chance of withdrawing acetone from the acetylene cylinder, no more than 1/7 of the contents should be withdrawn per hour. This acetylene cylinder contains approximately 300 cubic feet of gas. So using the 1/7 rule, I can use up to 43 cubic feet in the first hour and not withdraw acetone from the cylinder. This smaller cylinder contains approximately 150 cubic feet of acetylene, and I can safely use about 21 cubic feet in the first hour and not withdraw acetone. If additional gas volume is needed for a particular application, cylinders must be manifolded together like this. Remember, adequate gas volume is essential for the efficient and safe operation of all gas apparatus. Acetylene cylinders must always be stored in an upright position in order to keep the liquid acetone properly contained. There are many other types of fuel gases, such as MAP gas, a group known as the propylenes, natural gas, and propane. Each gas has specific burning properties, temperatures, and operating pressures, and each requires specific apparatus. For complete information about oxygen and fuel gases, cylinder care and handling, and appropriate equipment, talk to a gas supplier or refer to your safety and operator's guide. Now let's take a look at the components of a typical oxy-fuel system. This is a typical oxygen acetylene setup using a small heating torch. Pressure from the oxygen and acetylene cylinders is reduced to working pressure by the regulators on each cylinder. Cylinders should not be used without proper pressure-reducing regulators. The delivery pressure data for the selected tip or nozzle is found in an operation chart like this. Charts provide specific pressure and gas flow requirements for individual tip styles and sizes. Hoses carry the gases separately to the torch handle, where each gas is controlled by a valve. Before lighting, the valves are used to purge or clean out each line independently. The fuel gas valve is then opened, the gas ignited, and the flame adjusted. Then the oxygen valve is opened and the flame readjusted until the desired flame configuration is achieved. When you use the proper equipment and follow correct procedures, the oxy-fuel process can be accomplished safely. However, it is necessary to be aware of potential hazards, which, if ignored, can result in serious injury to the operator and damage to the equipment.